Look, we were talking about PV prices. I think what is clear is there's a lot more innovation to happen. I gave you one example of going from multicrystalline to monocrystalline silicon, which can improve the efficiency, and as a result of efficiency, it can also reduce the balance of plant costs. This is not rocket science. Mono is already being used, but not as economical, and it'll get better from where things are. There are many such examples. As I told you, we have more than 80 odd projects. Let me give you another example, which is sort of interesting in the context of India. What we notice is panels get more dirty in India than any other country in the world. And when sand or clay or dirt sits on panel, it blocks the light to some extent. As a result, you end up generating less, and this losses can be 3-4%. When you think about a 100 megawatt plant, 3-4% is massive amount of money. So, we normally, I'll give you an example. In the US, we used to clean our plants maybe once a year or once in 6 months. In India, when we started about 6 years back, we were cleaning it about once in 2 months, then we increased the frequency to once in a month, and then we tried twice a month. It becomes a huge nightmare if you have to clean it very frequently because you need a lot of manual labor in cleaning the panels. When you think about solar, most of the operations and maintenance is really just cleaning your panels and cutting the grass so that the grass or plants don't grow too tall, and shade the panels, which can then obviously reduce the output from solar. So we've been working with a few companies to implement a air cleaning system, which is a robot. I mean, think of the panels, arrays, the pictures you've seen. On top of that, we can install a robot with compressed air, and the compressor and everything is there. You don't need to, it's not big equipment, it's very, very small, which pushes with a toothbrush-like brush without using water. It cleans the dust in the panel, and we find that you get about 3-4% more energy. So in the context of India, when you say 5 rupee tariff, if you can implement this system, you can shave off 15-20 paise per kilowatt hour per unit. So that's an innovation. Small, it's not rocket science again, it's not a new rocket engine, but it just is a simple idea that can reduce the cost of cleaning as well as can improve electricity generation. There are many, many such ideas. So the point I'm making is it's still a young industry, a lot more innovation is happening. We are just one participant in the industry, and a lot is being done to reduce the cost. So my view is, PV prices will continue to come down. It already is at parity with imported coal or wind in India, and it's going to reduce, the costs are going to come down even further, right? So is there viability? The present prices that you've seen in the bids, 434, 463, it is a stretch. It's not easy at all. When we bid at 463, obviously there are a lot of assumptions that go into being right. It's not with today's prices. The assumption are these plants will have to go into construction 9 months from now. And since the industry is so dynamic, we're trying to see where will the prices be for panels, where will the prices be for electronics, where will the prices be for construction cost, what will be the cost of steel, what will be the exchange rate of yuan, what will be the exchange rate of INR to dollar. All of these variables, everybody has to take a view, right? The one good news is I think the projects that the government has put together, it significantly reduces the risk because the solar park is being provided by the government, evacuation is being provided by the government, and when that happens, which are usually from a development perspective, that's the biggest problem. When the government is giving you land, when the government is giving you evacuation, suddenly it's much easier to implement the project. We can build a 100 megawatt solar plant in 6 months, 4 months. We have actually done it repeatedly. We've done in Chile, a 100 megawatt plant in about 4 months from start of construction to. So I don't think any other sector, the power sector, where you have this speed that you can see. So as a result, the risks are significantly lower. And because the risks are lower, we are assuming that the lenders into the market are going to be more aggressive as well in their credit spreads. We're expecting that maybe we'll get 50 basis points lower cost of debt into the project relative to the regular project with the state discom. The I think the other benefit that the current bids have is, I think the government has obviously done a phenomenal job in architecting the Uday scheme in trying to improve the health of the discom. So there is a certain general assumption that the offtake risk in the country overall is going to improve as well. So you'll see that all of it gets priced in. It is very difficult to, as a developer, as an owner of an asset, we have all of these factors. Many of these are tending in the right direction. So yuan is depreciating. When yuan depreciates, everybody buys their modules from China. We do as well. And you do get a break. We think that just the depreciation itself has resulted in the module prices being lowered by about 3-4%, which is equivalent to the depreciation which many of us did not anticipate. Beginning middle of last year, nobody would have expected this, but obviously China has cause for this. So that's what goes in. So I wouldn't suspect the viability, but yet you have to assume that there is a lot of factors that have to go right. If the rupee goes to 70 or 72, then many of the projects will not get built because that's not what has been expected. I think it's probably possible to still make a decent return of somewhere in the range of 14 to 16% project level equity IRR pre-distribution. So equity IRR, FCFE IRR can be at that level of 14 to 16% at these levels that you're seeing. So if you call it viable, fair enough. If you're in some other business, I can put money in real estate and make 20%. For me, less than 20% is not my viability, then this is not your cup of tea. Obviously, you're not going to be able to make 18 to 20%. So generally, I think private equity driven platforms are going to find it hard to make investments at these levels. They would expect a couple of 100 basis points better returns. Another thing to keep in mind is 70-75% of what has been won in solar, concessions won in solar in the last 3-4 months. There was an article by Bridge to India where they said 75% of the bids have all been won by foreigners, non-Indian developers, which is a very good sign. I don't think in infrastructure you see such a mad rush of external capital, equity capital being interested in the country, which is a very good sign that the world is looking at. I think India solar has definitely become a center stage for the entire renewable industry. I think thanks to Honorable Prime Minister, who did a phenomenal job at COP21, launching the International Solar Alliance along with 100 plus heads of states. He's made India's response to climate change as solar. And in the process, he's also become the world solar statesman. The amount of attention that Honorable Prime Minister has brought to solar and the Honorable Energy Minister, Mr. Piyush Goyal, everywhere they go, they really have systematically addressed a lot of problems, which is what is the result we're seeing. So many companies from, Fortum of Finland, ENGIE of France, EDF of France, so many other large, Enel of Italy, large mega corporations are all coming to India to make investments in solar because the government has heard to us and all of these other foreign investors that are willing to come in and deploy. And all of us, I think there is a certain strategic interest in the business to create a platform. So there is a willingness to take a lower equity return than perhaps if you had other fungible uses for money in India. So please don't, it's too hard for us to judge and say 14% return is ridiculous. Why should anybody be taking, I can put my money in stocks in India and make more money. Right? Not in the recent few weeks, but hopefully generically. So I wouldn't want to pass on a value judgment on somebody else's decision. What you have to be aware is a lot of sophisticated companies are doing their analysis and they have certain written expectations, and it's not some fly-by-night operators that are bidding and trying to win at these current levels. So my response would be yes, it is viable. Is it going to go down in a hurry? Probably not, because we're finding that the numbers are already quite tight. I think we've talked about some of the technological challenges. I think a lot of focus on storage is happening. I would say storage is today where solar was probably 8-10 years back. I wouldn't think that large mega utility plants is going to start having storage. We're deploying storage. We're probably one of the largest developer with storage in different countries, but in the US we're deploying storage where, storage just for energy generation is too expensive right now. If I were to put storage and put a megawatt solar plant, my cost will go to 10 to 12 to 13 rupees per unit of electricity. Nobody would want to do that right now. And so I would say storage is being used strategically to do certain specific services right now. In the context of electricity market, for instance, frequency modulation. What happens is, if I'm a grid operator, I'm running 50 hertz, and I suspect that because of some excess demand or some generation going down, I'm dropping to 48 hertz, I can immediately call upon my storage assets to pump in some energy for a few minutes. That's called frequency modulation service, or broadly known as ancillary services, and we are contracting such frequency modulation services in utilities in California, for instance, right? Those are very pinpointed, specific usages that's available. And the beauty of storage relative to gas-fired peaker is gas-fired generator can only generate electricity. The beauty of solar is not only can it give you electricity, but can absorb electricity as well. So the frequency is high, and some amount of electricity or energy needs to be absorbed. So the beauty of solar is in modulating those slight changes. Storage is very, very valuable, and it's those types of services where you'll see storage deployed first, rather than straight energy generation, generating solar in the daytime, adding a bunch of solar, and start supplying storage-driven electricity from 5 p.m. till 8 a.m. next day. I think that, in my view, I think is probably somewhere between 5 years and a decade away. But nevertheless, that's technologically, I think, an area which is getting a lot of attention. Rooftops. Look, we have done rooftops in India for 6 years. We're probably the world's largest rooftop deployer in the world. We've done thousands of projects with rooftops, half a megawatt, several megawatts. The first project we built in rooftop solar was in 2011, supplying power to Standard Chartered Bank's operations in Chennai on a power purchase agreement model. We're not a rooftop EPC company, but we're a rooftop electricity provider. We, as a provider of electricity using an asset ownership model, we found the rooftops to be painfully complex. It's one thing that, if I'm the landlord of this building, I'm the user of electricity, and I call a EPC contractor to come and set up a 100 kilowatt or a 200 kilowatt rooftop, that's okay. I think it will work. Even that, what happens is, the roof space in India, generally, if you look at the electricity segment, you have residential users, commercial users, industrial users, and agriculture users. Agriculture is obviously deeply subsidized. Commercial, not subsidized. Commercial pays for everybody else's. Industrial and residential is also somewhat subsidized. So it becomes the first segment where rooftop solar becomes competitive is actually in the commercial segment. A building like this, a hotel or an office building or malls, these are the places where you can start supplying solar power and be competitive with the commercial tariff, right? The problem though is many of these buildings are reinforced concrete, and the roof space is a valuable space of real estate. In office buildings they use it as a cafeteria, hotels use it to set up their HVAC equipment. If you go and see the top floor of this building, you'll see that there are a lot of chillers, other equipment, and it's very difficult to put solar. You will come up with all this analysis and say that this hotel is a 4 megawatt, 5 megawatt type energy consumer, and I can do 50 kilowatts. You can do 1%. So yes, you can do 1%, and you can call yourself at St. Regis in Mumbai is green and have a ribbon cutting ceremony and all that, but does it really deliver any appreciable amount of energy? Can you really make huge economics out of it? Probably not. So our own view is commercial rooftops where it makes economic sense ends up having a lot of alternate use of rooftop space. The other issue is, if I'm going to be an asset owner in this building, I need to have unfettered access for the next 20-25 years. My numbers work out only if I know that I can own my asset and deliver electricity in a 20 or a 25-year model. Even 15 years, it becomes hard. So in a 20-year model, will the landlord of this building give me a clear right, which is bankable? When I go take it to a bank and say, I want to raise 70% of this is project debt, the bank looks at the documents and say, yes, you have absolute access to the roof. The landlord cannot stop you. You can go modify your power plant, but that doesn't work. It's very, very difficult. Everybody's worried that if I go put my plant here, if some dispute happens with the landlord, he might just shut me off. He may not let me in. What do I do with my asset? So these are all, the property right is a huge issue, and it's not a small issue. We've had to fight in the US in many, many cases, right? A building may not have a life of 20-25 years. What do you do then? Or the building may be sold. The current buyer of electricity may sell this building to somebody else. We need a right that when the building is sold to someone else, the rooftop solar, along with its agreements, will have to be bought by the new buyer of the real estate. Absolutely nobody in real estate will very easily agree to it. We've had to deal with these issues for ages as one of the largest commercial rooftop suppliers of electricity. It's not an easy task by any means at all. So I think it's a very important thing. Economically, rooftop makes a lot of sense because you don't have to waste transmission losses. You're using it at point of use, so it's much more valuable. But the real practical challenges are very complex, not easy to sort out. So we after having done 6 years of work and continuing to break our head, I have a separate rooftop group. Basically, I would say that it's a very difficult sort of asset class to develop. A lot of rooftops by the landlord just setting it up and giving it to contractors to set up will happen, but business models around rooftops is going to be a long shot, I think. It's going to take a lot of time. Solar and wind. Look, in India, I'll somewhat simplify. In India, wind generates a few months in a year, let's say 4, 5, 6 months in a year. And it generates usually in the evening time all the way to the morning time. It's a huge problem for the transmission operator because we all don't consume energy in the middle of the night. We're obviously consuming energy during the daytime. In the night time, the consumption goes down significantly. When the consumption goes down significantly, it's hard for the operator. He already has surplus energy. So India does not have deficit of energy in the middle of the night. From 10 p.m. to 6 a.m., India probably has enough energy to supply everywhere. There's power and there's no blackout usually between the middle of the night. Usually there is a blackout, then there's some problem somewhere. The line has gone down, but they don't do rolling planned blackouts from 10 p.m. to 6 a.m. because generally there is excess energy available. So when wind is generating at that time, it becomes hard. If I'm the Tamil Nadu transmission operator, I end up backing down on wind because at that time I don't need to pay to the wind developers, wind owners, because I have excess energy at that time. I'm running thermal power plants which have a certain minimum limit. See, you can't take a coal power plant and run it at 30% utilization. There may be a technical limit which is maybe 60%, 65% or 55%. So you can't back down on your other generation sources. So what do then? You then back down wherever possible and wherever the tariff is higher. Obviously, as a distribution utility which is making losses, if I can avoid buying an expensive price for electricity, I do that. So as a result, a lot of wind gets back down in Tamil Nadu and other states. Because of that, there is really no way to address it. Some countries have addressed it by saying that renewables will get a firm dispatch, and it's not a merit or a dispatch, but just renewables will be treated special, given that it's so important for the society. All renewables will get consumed. I don't think India has that law. I think in the case of wind, they're fighting for it. We'll see if it happens. Solar does not have any of these problems. Solar generates during the daytime. It's quite even throughout the year. And I think will not, in our own view, curtailment risk for solar or backdown risk is significantly low because of the fact that it's generated during the daytime when mankind consumes power. Fossil fuel for automotive. Look, based on a little bit of work we've done in electric vehicles, what is clear is, just like there is grid parity with solar and wind with thermal power, clearly there is parity depending on certain situations between gasoline-driven cars on a per unit kilometer driven. So if you were to look at levelized cost of driving, right, if there was such a metric, so we think the crossover is happening in some parts of the world, obviously with some subsidy. I think in the case of United States and California government, they give some kind of a subsidy, which makes the levelized cost of driving with electric vehicles cheaper. I was in Oslo, in Norway, earlier this year, and the number of electric cars is mind-boggling. I've never been to a Hertz rent-a-car counter where the fleet, they show you half of the fleet is actually electric cars. So this phenomenon is happening a lot faster than perhaps we all will believe. It will obviously happen in India as well. I think Tesla is coming up with its common man's version very soon. So I think it's only a question of time that the fleet is going to get displaced and replaced by electric vehicles. Then what do? If solar is the cheapest form of electricity and the entire automotive, I think the world has about 13, 14 terawatts of power. We think that the power generation requirement will have to be doubled as the vehicles switch to electric vehicles. So by 2030, the world may need to have 35, 40 terawatts of power, and all this new generation that has to be set up, solar will take the lion's share of it. But the problem is, it's not possible to run the whole world on solar because solar doesn't generate 24/7. So as a result, you do need to coexist with other forms of generation that can make up for the infirmness, or as well as the fact that you need power between 5 p.m. and 8 a.m. as well, in addition. What is clear though is, if you did the math, there may be 15, 20 terawatts that are needed in the world in the next 15, 20 years. And so as a result, it's our estimate that solar will receive an investment of about $5-6 trillion in the next decade and a half. Massive. In the context of India, we're talking about targets in India. The government has said that they'll do 100 gigawatts of solar, 175 gigawatts of wind. Sorry, renewables, right? Wind, there is already about 20-25 on the ground. Solar is about 5. So we already have about 25-30 gigawatts, and the government is talking about additional 145 gigawatts. Of the additional 145 gigawatts, solar will be about 95, and wind will be the remaining. So 2/3 is solar, 1/3 is wind, according to government's own projections. Why should that be? Clearly, the government believes that solar is going to be the winner going forward. That's why in their own planning, the next 7 years, right, 6-7 years, by 2022, the government has said, is it possible? Honestly, I think this will be blown away. Because A, the speed is phenomenal. Solar can be set up very, very quickly. China is starting to do 15 to 20 gigawatts of solar a year. India has plenty of land. Oftentimes people come in and say, is land a problem? The projects that we're setting up in solar are in the middle of nowhere, where the land is not used for anything. I was making up an estimate that so if you think about 2030, for instance, if you fast forward to 2030, it's expected, based on World Bank and other studies, this is in 15 years, right? Hopefully all of us in this room will be alive and kicking. And what we'll see is in the next 15 years, India will have to triple its power generation capacity from the current 250 odd gigawatts to about 750 odd gigawatts based on India's growth. And that means 500 gigawatts of new capacity has to be added in India. So if you look at where things are in the world today, Germany, for instance, in summer months, 50% of the country's electricity comes from solar. So there is an existence proof that a country can run with 50% electricity. So if I were to assume that by 2030, India learns all the technological tricks, because solar will become the cheapest, so economically it's not an issue. But technologically, India figures out how to run the country's energy mix technologically, where Germany is today. So even if we were to lag 15 years, and by 2030 out of the 750 gigawatts of energy generation capacity, 50% came from solar, that's 350 gigawatts. But 350 gigawatts is power. Solar produces only 6 hours a day, or about 1/4. So when you say power, in energy terms, you have to multiply solar by 4 times. So 350 gigawatts in 2030 equals to about 1.4 terawatts with solar. That's just massive amount of, and even if I were to assume $0.7 or $700,000 a megawatt, you're looking at $1 trillion which will get invested just in India between now and 2030, right? I think it's unavoidable because of economics. Once the technology has become the cheapest source of power, every leader wants to fill the gap and make sure that the country gets the power. Projects get done very, very rapidly. We build projects, as I told you earlier, hundreds of megawatts in 6 months. So it's our view that India is obviously going to see massive amount of investment going into this sector because of that. So I'm not a believer that the targets are unreasonable. I think the targets are going to be surpassed when we come to 2022 Indian renewable target. I think I've covered almost every question in the list that I've written down originally. I'm happy to take more questions if Edelweiss organizers feel that there is more time. See, Gordon Moore was one of the founders of Intel Corporation, along with Bob Noyce and Andy Grove. All three of them founded Intel Corporation in 1964, I believe. Gordon Moore worked on the manufacturing side of the business. In the case of semiconductors, what happens is the Moore's law that he was referring to is named after one of the founders of Intel. In that particular case, what happens is a chip is nothing but, think of it as thousands to millions to billions and tens of billions of switches, just like the switch we turn on and off. our ability to print smaller and smaller switches ensured that we can print more and more switches every passing year. So what drove Moore's law is primarily the ability. So it says that every year and a half you can cut cost of semiconductors by half or increase the functionality by twice. All it essentially meant is the ability to print switches like this in the transistor increased 2x every year and a half, which is called technology node in semiconductors. Honestly, that's got nothing to do with solar. Even though solar is made on silicon, the semiconductor is also predominantly made on silicon and it's printed. Here, the economics that you're seeing have got nothing to do with printing, which drove the Moore's law for decades. So we just have to make sure that we understand that Moore's law refers to the semiconductor economics and doesn't really apply in the context of solar. But the material of choice is still silicon. Now, what has changed in silicon over the last 5-10 years, making solar so cheap today? You know, solar panels 15 years back probably were, I don't know, I'm just going to guess. I think the data is there in the presentation I have. It was probably $40 a watt peak. Today it's 45 cents a watt peak. So it's come down 100 times in the last 10, 15 years, right? What has happened is, why has it come down? If you break up the solar value chain, it's very important to understand the manufacturing ecosystem of solar so that you can see where the costs have come down. The first step is, and I'll answer the question around make in India and what should we be doing to manufacture in India. I think we'll answer both the questions. So the first step is making silicon, right? How do you make silicon? Obviously, silicon is the third most abundant element on Earth. After oxygen, nitrogen, silicon is available in abundance everywhere. We know it as beach sand or quartz mines have silicon. They are nothing but beach sand is nothing but silicon with 2 atoms of oxygen, silicon dioxide. So if you strip away the oxygen, which in chemistry is called reduction, if you use carbon and burn a bunch of quartz, you'll be left with silicon. And that's how the world starts to make silicon. But that silicon is very, very cheap. It's $1 a kilogram. It's called impure metallurgical grade silicon. It's only about $1 a kilogram. That's not the silicon that goes into manufacturing solar cells. You have to purify this because that silicon is only about 95% pure. You have to go from 95% purity to 6,979, which is 99.99999% pure. So what you then do is, that is the manufacturing of silicon, which is billions of dollars. You know, earlier, about a year ago, we had announced a partnership with the Adani Group to do about $4-5 billion investment. It would be for manufacturing silicon, which is very pure, 99.9999% pure. You start with the material and you purify it or refine it. That technology, in my view, is the heart of solar manufacturing. If India as a country aspires and wants to have energy security, the beauty in solar is, if you go back to my point earlier, that vehicles are going to get converted to electric vehicles. As a result, oil is going to have a lesser role to play in India even in 15 years. Electricity, solar is going to become the cheapest. So the number one source of energy is going to be solar. And the number one material, the equivalent of crude oil in this new universe, is going to be silicon. If we don't get in today and manufacture silicon, just like oil has played havoc in India's macroeconomics for decades, we'll face the same situation with silicon becoming as important as oil is today. Just no way to avoid that. So that is the first step of manufacturing, which has gotten significantly better. It used to be that cost of manufacturing of silicon 10 years back would be about $25-30 a kilogram. Today, you know, we have a joint venture with Samsung in Korea, where we can manufacture silicon at $10 a kilogram. So silicon manufacturing costs have come down because of technological change to about 1/3 of what it was about 10 years back. Now you take the silicon. Silicon is nothing but, think of it as a shiny rock. You know, when you see silicon and you touch it, it's a very, very shiny, metallic looking rock. You have to melt it and you have to make it like a bread loaf. And then you slice the bread loaf into pieces of, you know, like 6 inches by 6 inches wafer. Square wafer. That is called ingot making and wafering. Now those two steps of manufacturing are also quite massive and capital intensive. And if India wants to get into manufacturing, I think I would say make polysilicon, make ingots, make wafers. That will secure energy security, as well as that will be the area where I think we should support manufacturing, because it will be advantageous for India and avoid forex trading out of the country. That has also significantly improved. So I'll give you some example, right? When you think about why the costs have come down. Silicon is a very brittle material. So when you have to make one wafer of silicon, you have to grind and make a wafer. So that abrasive grinding, you lose as much material as you make in one wafer. So essentially the industry, you can think of it as 50% of the material is lost in silicon. So what we do is, we have a steel wire with embedded diamond, so that the material can be recovered instead of using an abrasive material that grinds the wafer. We just use water to grind the wafer, and so we recover about 70% of the loss of silicon. This did not used to happen 5-6 years back. It is happening. So anyway, I don't want to go into too much technical detail, it might just get boring for you. But the fact is, I think it's these innovations that are on top of economies of scale. You know, just 5 years back, the world probably did 15-20 gigawatts a year. This year, the world will do 60-70 gigawatts a year. So there is more than 250 gigawatts of installed solar capacity today, while 5 years back it was 30-40. So there is just massive economies of scale that the industry is learning. There's probably 100,000 people employed in China alone in the solar industry. So I think it's a combination of economies of scale, innovation and unit operations that drives the economy. And from a manufacturing side, India is going to be a massive market, and India should strategically look at investing in the more difficult, more value-added parts of the value chain, instead of just making module and cells, which are the easiest part and will not contribute to much strategic advantage for India. How are we going to do this? Alright, I think I've covered sort of cost structure. There are no environmental issues to my knowledge. I'm not an environmental scientist. We've never faced a problem in any of our assets with birds dying or anything. So I am not aware of what you're talking about. But I'll go and check. I may be wrong and I may not be. How do you define grid parity? I mean, we generate electricity cheaper than what this building pays for. We generate electricity, we're bidding at 463. If you ran a bid with imported coal, nobody will bid 463 flat for 25 years. Absolutely not. If you give them concessional coal, maybe they will. So, all things said and done, I would consider that we have reached grid parity. If you give concessional coal, then it's a different matter because you subsidize it.
When do you reach 3.5?
When do we reach 3.5? Maybe a few years. I mean, 2 or 3 years. Right? It's very hard to say exactly when, but we'll get there in a couple of years.
How do states buy at a higher price rate when they don't have money to buy at 3.5?
Look, I think they have to do their planning. They're obviously, states are deciding to do a certain amount of solar. We're taking the risk that they've done their planning and they'll be able to buy. If they don't buy, then we'll have to end up in courts and regulators.
Do your PPAs have guarantee of it?
No, they don't. They don't. There's no concept of green generation. Almost everywhere else in the world, renewable does have a concept of deep generation. Indian PPAs don't have that. Thank you very much.